Good morning, everyone. My name is Arkadiusz and I am presenting joint work with Katarzyna KOSIAK and Professor Piotr ZWIERZYKOWSKI from Poznań University of Technology. Today, I'd like to talk about AidMap, a civic technology mobile application for reporting urban accessibility barriers built with Flutter and Huawei mobile services. Let me start with the problem we are addressing. According to the World Health Organization, around 1.3 billion people, roughly 16% of the global population, live with some form of disability. In Poland specifically, a national audit by the Supreme Audit Office reviewed 94 public facilities across 24 municipalities. Not a single one passed as fully accessible. This isn't a handful of isolated oversights, it's a systemic gap, and it's one that mobile technology is well positioned to help document and address. But for some people, there may be a technical complication. Since May 2019, new Huawei smartphones ship without Google Mobile Services (GMS) following US export restrictions. That means any app relying on Google APIs for maps, location, or push notifications simply won't run on a substantial portion of newer Huawei devices. Huawei's answer was to build a parallel ecosystem, Huawei Mobile Services, or HMS, with its own SDKs, called Kits, and its own App Store, App Gallery. AidMap targets exactly this gap. For the framework, we chose Flutter. It compiles a single Dart codebase to Android, iOS, and other targets, and crucially, the HMS core team publishes official Flutter plugins for their kits we needed, meaning no native Android code on our side for any HMS integration. We went with an HMS-only strategy. Given our target context and the project's focus on the Huawei ecosystem, supporting GMS in parallel wasn't necessary right now. Their architecture is straightforward. A Flutter client communicating with a Flask backend over REST, hosted on a private VPS with the app distributed through App Gallery. The HMS layer sits between the Flutter application and the underlying system services. Each kit we use talks to the corresponding HMS core service installed on the device, replacing what a Google Services dependency would otherwise occupy. We also prototyped a conversational AI assistant using the DeepSeek API, though that component isn't evaluated in this paper. In terms of which kits we deployed, MapKit handles the base map and barrier visualization, LocationKit provides user coordinates, NaviKit powers turn-by-turn navigation and surfaces accessibility barriers along a route, SiteKit covers place search, and AccountKit handles authentication via Huawei ID. No separate AidMap account needed. PushKit was deprioritized due to time constraints. One feature we were unable to deliver was augmented reality, overlaying accessibility barriers onto the camera feed. We evaluated 4 options on our development device: a Huawei Nova 12S with a Snapdragon processor. AR Core requires GMS, rolled out by construction. AR Engine, Huawei's own solution, only runs on Kirin-based hardware. AR.js failed because Huawei's proprietary WebView couldn't load the WebGL and camera pipeline, and a custom FreeJS implementation exceeded what a prototype team of 3 could absorb. The conclusion is a structural gap. On Huawei hardware today, there is no AR solution that is both GMS independent and not locked to a specific processor family. On the positive side, integration went smoothly. The official HMS Flutter plugins closely track their GMS equivalents, which kept the learning curve short. Flutter's own rendering engine also helped. Because it doesn't wrap native UI widgets, we could concentrate integration work on the handful of system service touchpoints rather than reworking the entire UI layer. The app was published on the App Gallery and operated correctly on Huawei devices without GMS, which was the primary goal. Beyond AR, the main constraints are distribution reach. App Gallery's user base outside China remains small compared to Google Play, and a thinner documentation and community ecosystem around HMS compared to Firebase and GMS. For developers considering this path, an HMS-only approach makes sense when your target market has high Huawei concentration and your requirements don't run into the AR wall. Otherwise, a single build with runtime service detection is the safer default. To summarize, AidMap demonstrates that a functional Civic Tech application can be built on HMS and Flutter with zero GMS dependency. The core feature set, maps, location, authentication, and navigation, all delivered. Three directions follow naturally, moving to a single build setup supporting both ecosystems, conducting field testing with real users in an actual urban environment, and completing the planned migration to Huawei Cloud infrastructure. Thank you for your time.